Alright guys, today we're going to start looking at series and sequences. So sequences are actually something that you've looked at before, and that's what this first example here is. If you look at this pattern, 1, 3, 5, 7, 9, you guys can all figure out what these next numbers are going to be. But what we have to do is come up with a sequence for the nth term of this. So what a lot of people will think of is they'll realize that every time I'm adding 2. So they'll try to write their sequence as n plus 2. Now the problem here is whenever you write a sequence, you need to remember that sequence is going to be in terms of which term number this has. What that means, for example, number 1 is the first term. Okay, number 3 is the second term. 5 is the third term, and then all the way through 9, which is the fifth term. So n in this case stands for the term number. So in order to have a sequence that works for this set of numbers, I have to be able to plug in n and get that value. And if you look at this very first number, if I plug in 1, 1 plus 2 does not give me 1. So I can't use n plus 2 as my sequence. Now a lot of you guys learned this in Algebra 1, because you saw a sequence like this. You know this sequence would end up being 2n minus 1. And we're going to talk a lot more tomorrow and the next day about how to actually write some of these sequences. But for now, what we need to realize is that when we have a sequence, it's going to be denoted as a sub n, where n is the term number. Okay, so n is my term number. So if you look down here at these examples, we're going to find the first 4 terms, and we're going to find the 100th term. So for example, if I want to find the first 4 terms of this sequence 1 over 2 to the n, I'm going to start with my first term. Remember, n stands for my term number, so the first term is denoted as a sub 1. So a sub 1 is 1/2. A sub 2 is 1/4. A sub 3 would be 1 over 2 to the third, and a 4 would be 1 over 2 to the fourth. If I were to find the 100th term here, I would just plug in 100 where there's n, and I would get 1 over 2 to the 100th power. I don't actually have to calculate that number, it's going to be a little too big for me. Alright, these next 2 sequences are very similar to each other. So this first one, -1 to the n power. If you notice that -1 is in parentheses, which makes a difference. So if I were to do the first term, that would be -1 to the first power. -1 to the first power is just going to be regular old -1. Okay, but if I move on to the second term, when I square that negative in parentheses, it becomes a positive 1. If I raise it to the third power, a negative times a negative times a negative is negative. But then if I go back to the fourth power, I get a positive number. So what's going to happen here is I'm going to alternate signs. So what this is helpful for is if you're trying to write a sequence with alternating signs, any sequence can get multiplied by this -1 to the n and give you those signs alternating. Now let's say I wanted the same thing, but instead I want that first term to be positive. Well, let's look at this next term I have on here. If I have -1 to the n plus 1 power, a sub 1, I'd plug in 1 for n, and that would be -1 squared, which is a positive 1. If I plug in 2, that would be -1 to the third, which would be a -1. And so on. It would still alternate signs. It would just be the opposite of what we had. Alright, so the next kind of sequence we're going to talk about is a recursive sequence. So the way a recursive sequence works is that the only way to write a recursive sequence is if you know the first term or terms, depending on how you write it. Because a recursive sequence is based on the previous terms. So what that means, this example down here is an example of a recursive sequence. It tells you what the first term is. I know my first term is 1. Then I'm going to use this recursive sequence to come up with the next couple terms in my series. Now this looks a little overwhelming, but what you really need to understand here is a to the n minus 1. What that really means my previous term. Because let's think about how that works for a second. Let's say I'm trying to find the second term in this sequence. So if I want to find a2, I plugged in 2 for n. So that means I'm going to plug in 2 for n in the next part, which means a to the 2 minus 1 is really a1. And I know what a1 is. I already found a1. It's my first term. So my second term is just the first term plus 3. If I moved on to A3, that would be A2 plus 3. So it's the previous term plus 3, which ends up being 7. A4, next term plus 3. So the only thing that's tough about a recursive sequence is that the only way you can come up with your recursive sequence is if you know the term before it. So it would be really hard to come up with the 100th term of a recursive sequence because you'd have to know the 99 terms before it. One example of a recursive sequence that you guys have seen a lot of would be the Fibonacci sequence. Because each term in that sequence is based off of the 2 previous terms before it. So if we were to write that as a sequence, that would be, I'd have to define the first term, and in this case, I'd actually have to define the second term as well. And then this sequence would be written as the sum of the 2 previous terms. So a to the n minus 2 plus a to the n minus 1. But you don't need to worry about how to write one that's that complicated. That's just an example of a recursive sequence. Alright, so the next thing we're going to look at is partial sums. We're going to ignore this thing down here until we look at this first part. So partial sums, we're going to start with S1. S1 is the first partial sum, which means it's just the sum of the first term. And in this case, my first term is just 2 times 1 plus 3, which is 5. If I were to find my second partial sum, I would just take my first term and add it to my second term. So I already found my first term by plugging in 1. I find my second term by plugging in 2 for n. So 2 times 2 plus 3 is 7, which means my second partial sum is 12. So my last partial sum would be that third partial sum, and it's going to be the exact same thing, but I'm going to add my first, second, and third terms together. I already know my first term, I already know my second term, and I get my third term by plugging in 3 for n. 2 times 3 plus 3 is, can't do my math today. Wrote the wrong number there. My second term wasn't 12, my second sum was 12. Sorry about that, so that should be a 7 plus 9. Add all those up, and I get my third partial sum of 21. Alright, now the next thing we're going to talk about is series. Okay, so we talked about how this unit's about series and sequences. We just looked at sequences. Now we're going to start to look at series, which uses something called sigma. Okay, so sigma is a way to denote a series just very evenly and nicely. So sigma has 3 parts to it. The first part to it is the actual sequence itself. So that sequence, it's going to be written just like we've been writing sequences so far. It's written here as a sub I. I works the same way as n has in the past. Whatever variable you have there, you're just going to keep it. So this is going to look like something like 2n minus 1, or something like 3i plus 2, or 2 to the x plus 1. Any of those are examples of sequences I could have there next to my sigma, and that's just the sequence I'm going to use for this series. Then there's 2 other parts to it. The first part is the bottom of my sigma. So the bottom of my sigma, it's written as an I. Again, it can be any variable, but that variable is going to match the variable that's in my sequence. So if I use n, then down here I would use n. Okay, but that bottom number, what that tells you, that is your starting term. So that is going to be the term that I start with. So if I'm finding a series, which is basically, a series is just, let me write that definition there, it's your sum of certain terms in the sequence. So for this sum here, I would take my sequence and start with a number at the bottom. Then the last possibility I have on here is this top number. That top number, that's my ending term. So the 3 components of a sigma are the actual sequence, the starting term, and the ending term. Okay, so for example, if I had a sigma like this with 2x, let's say I had x equals 4 at the bottom and a 10 at the top. What this sequence would mean is the sum of terms 4 through 10 of the sequence 2x. So that would mean, for example, 2 times 4 plus 2 times 5 plus 2 times 6 all the way until I got to 2 times 10. And I would add all those terms together. Okay, so we're going to look at find an actual sum here. So this first sigma up at the top, it gives me the sequence, and it gives me the starting term, and it gives me the ending term. So if you read here, it tells me my starting term is what's at the bottom, which is 3. So I'm going to start with the third term. So the answer to this question is going to be my third term plus, and I'm going to keep adding terms until I get to the fifth one. So it's going to be A4 plus A5, or plus A3. So I just need to find those 3 terms and add them together. So my third term is 3 squared plus 2, which is 11. Fourth term is 4 squared plus 2, which is 18. And the fifth term is 5 squared plus 2, which is 27. Add all those numbers up and you got your answer. So the sum of that series from terms 3 through 5 is 56. So I start with the bottom number term and I end with the top number term. Alright, then for this last one here, I'm just going to take a series, and my little dot dot dots here are kind of hard to see. So there is a gap here. It goes from 3 to 4 to 5, and it keeps going all the way till 20. I'm going to write this in sigma notation. So what I'm going to do is I'm going to come up with my sigma. The first thing I need to come up with is my actual sequence. Now when you write something in sigma notation, there's actually more than one correct answer. So what I have here, if you guys look in every one of these terms, the 3 stays the same. So I'm going to have 3 in my sequence. The only thing that changes is that variable, and it's going up by 1 each time. So I could write the sequence as 3 to the x. And what I could say at the bottom, the term I started with was x equals 3. And then I kept going all the way until I got to the 20th term. And that is a correct answer. Now the thing about series, though, that make them nice is that you can vary these based on what kind of a sequence you write. So what also would be a correct answer is if I had sigma, and let's say I wanted to start with the first term. I could rewrite my sequence as 3 to the x plus 2. And then I would start at 1, it would still work. I would just end instead at 18. So there's a couple different right answers for what you can use for this. And we're going to talk a lot more about specific types of series and sequences as this unit goes on. And that's just a basic introduction to sigma and to series.